All right, we'll just give everyone a few seconds to settle in. Can you hear me okay? Raise your hand if you can hear me. Awesome. All right, my name is Gabriel Peal. I'm a software engineer at Tonal, and I used to be at Airbnb. Today, I'm going to talk really, really fast because we have a lot to cover in about 40 minutes, so bear with me. So we're going to talk about Mavericks. Mavericks is an Android architecture library built on top of Android Jetpack view models and Kotlin. And if you like buzzwords, it also conforms to MVVM, MVEI, and unidirectional data flow. But I'm not super into buzzwords. My colleagues and I started working on Mavericks about a year ago. At that time, we had about 75 Android engineers at Airbnb building product. And we saw them reinventing solutions to the same problems over and over again. This was really time-consuming, and it led to fragmented solutions and different patterns used across the codebase. At around the same time, Google introduced Android Jetpack, and specifically view models, that were aimed at solving these problems. Specifically, some of the conventional challenges around life cycles were dramatically easier after view models. So the life cycle that we see on the left is what you might be used to for fragments and activities, and on the right, we have the view model. It's much more simple because it survives for the logical lifecycle of your fragment rather than the view lifecycle. So when you rotate the screen, you'll actually get the same instance back, and you don't have to worry about save instance state for configuration changes or resubscribing to network requests or anything like that. In addition, we were starting to adopt Kotlin in a really big way. At that point, pretty much all new code was written in Kotlin. But Jetpack required its compatibility with both Kotlin and Java. And we saw this as an opportunity to improve some of the APIs on Jetpack with Kotlin. In addition, it didn't try to solve every problem, so we figured we'd try to solve some additional problems that people were reinventing solutions for over and over again. So we started building Mavericks, and we launched it with a small pilot of about 14 Android engineers at Airbnb. After they shipped their first features, we asked them how they liked it on a scale from 1 to 10. And 13 out of 14 of those engineers gave it an 8 out of 10 or higher. So I like Mavericks, but don't just take my word for it. This is what other people were saying as well. So at that point, we opened it up to the rest of Airbnb. And pretty much overnight, it organically became the de facto way to write anything on Android at Airbnb, from simple static screens to some of the most complex screens in the app, like the reservation screen. And none of this was tied to Airbnb, so we decided we were going to open source it. And in August of last year, we open sourced Mavericks. And it was a beta, and we wanted to get feedback from the community. Since then, Mavericks has grown a lot. Inside of Airbnb, it's continued to grow, and today, there are over 350 unique screens written with Mavericks at the Airbnb app that they're shipping every week. That means that since we launched Mavericks, a new Maverick screen is added to the codebase every single day. In addition, it's grown in popularity, and many other companies have adopted it, including Tonal. And actually, as of this week, we've released a Castor.io course to help onboard new teams and released Mavericks 1.0, the first proper 1.0 release of Mavericks. Now, I could stand up here and show you 100 screens, 100 more slides as to why Mavericks is really useful for building products on Android, but I figure I would just show it to you instead. So this is my last slide. And now I'm going to hop out of the safety net of Keynote and do some live coding. Everyone tells you shouldn't do this, but I'm going to do it anyway. And this is why we're going to move quickly. So we're not just going to build one app today. We're actually going to build two. The first one we're going to build is a counter. I have it running on my emulator here. It has a text view in the middle of the screen. When I click it, a counter goes up by 1. And when I click Next Counter, it adds a new fragment to the backstack with a new count. So now let me know. Can you guys in the back see the code here? Raise your hand if you can. All right. I think that's pretty good. And there's some empty seats if you can't see, so you can move up. So what we have here is the code for a simple counter. We have a mutable integer property called count right here. And then we do a couple setup things. We set the enter transition just so you can see the difference between counters. We inflate a layout, all basic stuff. And then in onViewCreated, we use Android navigation components to navigate to a new counter fragment. Now, we're using navigation components. You could use anything. It has nothing to do with Mavericks, but I chose it here because we can do it with just one line of code. And then we set a click listener on that text view itself, which increments the count and updates the text view. And for the simple example, this pretty much works well. But things would start to break down pretty quickly in a real app. So if we increment the counter and then rotate the screen, it resets. Now, we could fix this, but it would take a little bit more boilerplate. We'd have to use save instance state or store that counter somewhere else. Or if we wanted to fetch some asynchronous data, things would get even more complex. Handling things like the loading state, success state, and error state all independently would start to become really cumbersome really fast. In fact, a lot of the time, people just choose to ignore loading states and error states because it's just kind of annoying and it requires a lot of boilerplate. And then God forbid if you want to handle rotation in that case or share that data between screens in a flow. So Mavericks is going to help us with a lot of this stuff. And view models actually, from Jetpack, solve some of these problems as well. So let's take one step in the right direction. Let's convert this to the Jetpack view models. So I've already added the dependency to my build.gradle file. And the first thing we want to do here is create a view model. So make class counter view model. And we'll make it extend view model. Great. So now we have a view model. And we need to recreate that count property that it'll own. So we'll make val count. And then we'll make it mutable live data. And it's an int. Now, in the current version of Jetpack, you can't set a default value on live data. So we'll have to set it up in init. So we'll say count.value equals 0. Awesome. Now we need a way to increment our count. So we'll say fun increment count. And then we need to increment the value. So we say count.value equals count.value plus 1. Now we have a little problem. IntelliJ, or Android Studio, is actually going to tell us that we can't add 1 to nullable int because we couldn't set an initial value on our mutable live data. So we need to give it an initial value or a default value of 0 just in case it's null. Now it probably won't be in this case, but for the type system, we have to do that. Now let's go to our fragment. And we no longer need this count property because we've moved it to our view model. And we'll just cut this update counter text for now. OK, so we'll delete that and delete these. All right, so now we need to get our view model that we just created. Now, as you saw in one of the 4 slides that I had, view models have a really convenient lifecycle in that they persist for the logical lifecycle of your fragment, which means that if you rotate your screen, you'll get the same instance back. That means we can't just instantiate a new view model in our fragment. So we're going to use something that comes with Jetpack called view model providers. So we'll make a private val view model, and we'll give it the type counter view model. And then here we're going to do by lazy. We're doing this by lazy because view model providers can't be used until after the fragment is attached to its activity, which will happen when any of our code is run, but not when this property is instantiated. So here we'll do view model providers dot of this. Now this is the scope for the view model. It could be this, in this case, the fragment, or we could put the activity, which I'll show you in a second. And we have to get an instance of the view model counter view model, which we give it a class reference to so that it can look it up in a map to see if it already has an instance, or it'll give us the existing one if it was already created. So now we have our view model. And the first thing we need to do now is wire up that click listener to increment that count. So now in the click listener for that counter, we'll say view model.increment count. And finally, we have to update the text view anytime it changes. So we'll say view model.count.observe. We need to give it the lifecycle owner because live data is lifecycle aware. And then a new observer where it'll give us the count anytime it changes and the fragment is started. And then we'll update the countertext.text. So if we rerun the app now, you'll see it should behave exactly the same for the most part, except now our counter will survive configuration changes. So if we increment it and rotate, it stays the same. And when we add a new fragment to the backstack, we have our fragment scope view model, so it gets its own. So view models can also help us persist data and share data across screens. So if we wanted to share that counter across fragments, all we need to change is the scope of our view model from this, which is the fragment, to not require context, but require activity, which is the parent activity of this fragment, so that all fragments in the same activity are going to share the same view model. So here when we increment the counter and then hit next counter, it stays at 5. This is pretty handy. But now let's take it one step further. Let's convert it to Mavericks. So in Mavericks, one of the key differences is that although it's built on top of Jetpack view models, instead of exposing individual live data properties that you subscribe to individually, your view model is now generic on a single state class that describes the entire state that the view model owns. So Mavericks enforces a few things, but let's get our project set up. I've already added it to the build.gradle file, and you can look in the GitHub repo to see how to do that. Now let's get it ready to be integrated into our app. I've done nothing except for that. Now, the first thing we need to do is update our activity. And in Mavericks and generally with navigation components, there's really nothing in the activity. It's more or less just a nav host or something that creates a fragment. So we're just going to change our base activity to base Mavericks activity. Now, you probably have your own base activity, and we recommend that you just make that extend base Mavericks activity. Or if you'd really like, you can just look at the implementation and pull it out into your own base class. That's all we have to do there. Now, the only actual class we have to make our app Mavericks compatible is our own Mavericks view model. So let's make a new class, Mavericks view model. And you'll see why we're doing this in a second. It's going to be abstract, class, Mavericks view model. And then it's going to be generic on that state. Now, as I mentioned, with Mavericks view models, your view model is generic on a single state class. And we give it an upper bounds of Mavericks state. It's just an empty interface that tags a data class as compatible with Mavericks and also can be used for things like ProGuard configs. Now, Mavericks is also going to create that initial state for you and give it to you automatically. So you want to give it a constructor parameter of the state and give it a type S, and then have it extend base Mavericks view model like that. Now, at this point, you're like, why are we even doing this in the first place? It doesn't seem to add any value. Well, it turns out that base Mavericks view model has a second constructor parameter called debug mode. And we're going to set it to build config.debug. So Mavericks itself has a series of debug checks that it only runs in debug mode to ensure that you're using Mavericks in a safe and performant way. But Mavericks doesn't actually know whether your app is in debug mode. So this is really the reason why we're setting this up. Now let's go to our fragment, or back to our fragment, and set it up for Mavericks. So as I mentioned, we're going to update our view model, but first we need to create that state class. So we're going to make data class counter state. It's going to have one property, and it's going to be an int. We'll initialize this to 0 and make it extend Maverick state. Pretty simple. Now let's update our view model. So now we're going to change counter view model to extend our new Mavericks view model class, and it's going to be generic on counter state. But you'll notice that we have that initial state constructor parameter. Mavericks is going to do it for us. So let's just do this, counter state, and then pass it to super. That's all we have to do there, nothing else. Now that we have our state, we no longer need this count property, like that. And then we need to now update increment count. So we have our state, it's going to default to 0, and now we need to create a new state incremented by 1. If you're familiar with React, this is going to look really similar. So there's a function called setState, and it's only available from within a Mavericks view model. Now this, you get a reducer. Inside of the reducer, this object, actually the context for this is the current state when it's called, and you're supposed to return the new state. So for verbosity, and to make it a little bit clear for this first example, let's do val like old state equals this. So again, this is the current state, and we're going to clean this up in 1 second. And then we want to return old state dot copy count equals count plus 1. Now copy is a Kotlin data class copy function. So let's clean this up a little bit. So it's a lambda, so we don't need the return. And since the this is kind of implied anyway, we can just delete this variable and just have copy. Now we can put it on one line and even set the entire function as an expression body syntax like this. So now with one line of code, we can easily see that we're updating the state to increment the count by 1. Now let's go back to our fragment. And we now need to make this fragment compatible with Mavericks. So we'll change the base class from fragment to base Mavericks fragment. Okay? Pretty simple. Although now you see that the class is red because we have to implement a new function called invalidate. Now, invalidate is a function that's very similar to the render function from React. Render automatically gets called anytime your state or props change for your component. And similarly here, invalidate will automatically get called anytime the state for any of your view models is updated. But now we need to actually wire up our view model with Mavericks. And this is one of the ways we were actually able to simplify the original Jetpack API because of Kotlin. So here, we're going to erase this entire lazy block with something from Mavericks called fragment view model, like that. And now it's basically going to wrap the same thing we just did and automatically subscribe to state changes in a lifecycle-aware way and automatically call invalidate when it changes. So we're going to cut this text again because we don't need it and delete that observable value. Now, everything else so far is the same. the navigation controller, both these click listeners don't need to be changed at all. Now in invalidate, we now know that this is automatically going to get called. So we need to update our text view accordingly. So the inverse of setState is a function called withState. And I'm going to use the same expression body syntax to simplify things, since this is a common pattern in Mavericks. So we're going to call withState, view model, and then it's going to give us a lambda with our state. And now we just need to update our text view. Instead of count, it's state.count. And now it should just work. So if we rerun the app, it'll relaunch in a second. You'll see when we click the text view, it increments. When we hit next counter, it goes to a new counter. And similarly with scopes, if we change fragment view model to activity view model, like that, if we run it again, it's going to do that same thing that we just did with Jetpack, where it's going to now activity scope this view model. So when we increment the counter, go to new screen, it stays the same. Now, all of this, a lot of this stuff that works under the hood, people only think about within the context of rotation. But one of the more edge cases for Android is that when your app is in the background, Android might actually kill your process. But first, it will give you a save instance state bundle to save some stuff that you can actually restore in a new process. And pretty much no one actually handles this correctly, but Mavericks actually makes that a little easier as well. So to simulate this, let's open up settings here, and we'll change the background process limit to 0. There we go. No background processes. So when we switch back to the counter app, and we switch apps, and come back, you'll see that the counter gets reset. And this is going to be the case, pretty much the behavior for most apps. But Mavericks makes it really easy to solve this. If you annotate your state properties with persist state, Mavericks is going to pull those out and save those so they can be restored in a new process. So if we increment the counter now, switch apps, and come back, it actually restores. We're in a new process now, but we've actually carried state over from the original app. All right, so we've done the first app. On to the second. So the second one's a little bit more complicated. Let's take a look here. We're going to build an app for our local dog adoption facility. So when we launch it, it's going to load a list of dogs from a dog repository. We can scroll through them, go to a details page where we can see more information about them. At the bottom, there'll be a little button that says, I love this dog. You can go here, now click on Wonder, let's say I love it. And you'll notice that the footer here now updates. When you click Adopt, it will do some paperwork, get the dog ready to be loved by its new family for about 5 seconds, then take you to the adoption fragment where you can actually see your dog and you can figure out how to meet it. So this is why we're moving quickly. We have a lot to do in a short amount of time. So I'm just going to go ahead and close this module here, and we'll open up something called dog fragment. If we run the app right now, it's pretty basic. It's not actually really doing anything at all. So it's just inflating a layout. Pretty simple. Let's get this set up. So the first thing we need to do, just like anytime you're setting up something with Mavericks, is to set up your state. So let's make a new Kotlin data class called dog_state. It's going to be a data class called dog_state, and we're going to make it extend Mavericks state. OK, now let's talk about what properties we want. We know that we have a list of dogs, and this is going to be shared across all of our screens. So we'll say val dogs, async list of dog. I'll explain this in a second. And we're going to initialize it to uninitialized. So what you might normally do in this situation with live data is you would maybe have like a nullable list of dogs and a loading state and maybe the error in case it failed. Well, Mavericks ships with a Kotlin seal class called async. Async is a seal class, and it has 4 subtypes: uninitialized, loading, success, and fail. It's generic on the success type, so you can invoke it just like a function just by calling property with parentheses, and then it'll return a nullable version of the whatever type that success type is. Or if it knows that it's a successful value, it'll actually return the wrap value. We're going to use this in a second, so if it's a lot to take in right now, just bear with me. Now, let's do a couple things here. We know that we want to fall in love with some sort of dog, right? That's the point of this app. So we'll do val loved dog ID, and it'll be nullable long, and then we'll initialize it to null. Now this is great. So the reason we're using love dog ID is because our list of dogs is the single source of truth for our data. We don't actually want to store the dog there as well, because if some information about that dog updates, we'd have to remember to update it in 2 places. And this is where derived properties come in handy. So here, what we're going to do is we're going to make a little function. This is just a class, so we can create functions and properties on it. So we'll do fun dog ID, and it takes a nullable ID, and then it's going to return dog nullable, right? So you can give it a dog ID, it'll return either the dog or null. So dog or null. And then we're going to say equal to dogs. And so this is where invoking these async property comes in handy, because here it'll either return a list of dogs if we've already fetched it, or null if we haven't. So here we have nullable dog dot first or null. It dot ID equals dog ID. Okay, this is all we have to do. And now, if we want to create another derived property for our loved dog to get the actual dog that we love, we can say val loved dog equals dog loved dog ID. Just like that, one line of code. Now we have a property that's always going to be up to date, and it's always going to have the latest information. So the next thing we have to do is to create our dog view model. So we'll make dog view model as a class dog view model, and then it's going to have the state, which is dog state. It's going to extend Mavericks view model, dog state, and it's going to pass in the state. So this is really standard. Pretty much all your Mavericks screens and view models are going to look like this. But we have this thing called the dog repository. Now, it has two functions. One, get dogs, and one is adopt dog. Now, I've made this simple for the case of this talk, but it could be a network request or a database request, anything like that. But here, I've just simulated it, so it returns an observable list of dogs that sleeps for 2 seconds and then returns a list to simulate that loading time. Similarly, adopt dog does something similar. It's a single. It sleeps for 5 seconds and then returns that dog. So again, this simulates an API request, database, whatever you'd like. But now we need to get that in our view model. So how are we going to get this? How are we going to inject this? So let's go back to our view model, and we'll add it as a constructor parameter, because that's really the ideal way. It makes it really easy to do things like testing. OK, so now we have it in our constructor, but Mavericks doesn't know how to get your dog repository. It could be in Dagger, it could be in Coin, it could be a global singleton. It really could be anywhere, so Mavericks can't do this for you. So if Mavericks notices that you have extra parameters in your constructor, it's going to look in the companion object of that view model to see if it implements Mavericks view model factory. It's generic on dog view model and dog state. And then it's going to delegate the creation of that view model to a function called create. Okay? Create gives you two parameters. It gives you that state that you should pass directly to the view model that you're creating, and also something called view model context. Now, view model context basically gives you access to things that should enable you to get to your object graph. So if we hit dot here, you can see you have access to your activity, your fragment arguments, your application class, anything like that. So no matter how you have your object graph in your application, this should be enough to at least retrieve the objects you need. So here, we'll say val dog repository equals view model context dot app. And then it's going to give us a generic form, so we can easily just have it casted automatically. And then what I haven't shown you yet is on our application, for simplicity, we have a custom application, and I've just created this dog repository as a singleton property on the application. Again, this is an example, but through your application or activity, you should at least be able to get access to your object graph somehow. So we'll say dog application dot dog repository. Awesome, we're getting closer. So now all I have to do is return dog view model, pass it the state that was given directly to us, and a dog repository. Again, you don't want to mess with that initial state because it handles things like persist state, like we saw before. And so you don't want to get in the way of that. OK, great. So now we have our dog repository injected into our view model. So in our init block, let's just subscribe to those dogs. So we'll say dog repository dot get dogs. And now we want to subscribe on schedulers.io. So again, this is standard RxJava. Mavericks uses RxJava under the hood and exposes some conveniences for RxJava, but it is not inherently tied to it. So if you want to use coroutines or anything else, you're more than happy to. Mavericks does not actually care. So now what you would normally do is something like this. You would subscribe, and then maybe set state, and then here you have your dogs, and then you say copy dogs equals success with wrapping the value. OK, so this is dogs would be up here. And then this is kind of a lot of work, and we haven't handled the loading state, we haven't added the error state, and then here you'd have to create you have a disposable you now have to deal with that you'd have to figure out when to dispose of. So Mavericks makes all of this way easier. So let's go ahead and just delete this subscribe block and instead call a function called execute. Execute is an extension function from Mavericks as a convenience on observable of t that will take your stream, it'll emit loading at the beginning, and then map on next to success, wrapping the successful value, and on error to fail. So now, all we have to say is copy dogs equals it, because it's now mapped this stream of t, which is list of dogs, to stream of async list of dogs. Great, 3 lines of code. We now have the life cycles properly handled, we have the loading state, we have the success state, and we have the error state. So again, this is one of the core cases that was really common that we saw at Airbnb that we think a lot of people do all the time that we really, really wanted to simplify. All right, so we're flying along here. Let's go to the dog activity here. And you can see we've already updated it to base Mavericks activity. And so now let's go to the dog fragment and update it. So we'll say now dog fragment extends base Mavericks fragment, like that. And then it'll ask us to override and validate. And then we need to get our view model, just like we did in the counter. So we'll say private val view model, dog view model, by activity view model. And we're just going to go straight to activity view model in this case, because we know already that it's going to be shared across different screens. And so here, now, just like our counter example, again, these screens start to look really similar, which is really convenient when you're working in a large app, because as you move around the code base, the code looks very familiar everywhere you go. So we say with state, view model, and now we have our state. Now all I have to do is render our dog state. And again, this is automatically going to get called in a lifecycle aware way anytime the state for any of your view models changes. So we're going to use Kotlin synthetic accessors to access the views here. Again, for simplicity, we have in our layout a recycler view, that button at the bottom, and a loading animation. So let's take this loading animation, and we want it to be is visible. This is from Kotlin or Android KTX, equals state dot dogs is loading. Great. So now the loading animation is going to be visible right when we're loading. And so now we have the dogs recycler view. And we're going to use something now. We want to take this custom view that I made called dog row, and we want it to be available in our recycler view. So normally if you wanted to do this, it would take quite a lot of work. You'd have to wrap this in a recycler view holder. You'd have to make a view holder layout. You'd have to make an adapter. It would take a lot of work. But instead, we're going to pair this with another library we open sourced at Airbnb called Epoxy. Epoxy makes it really easy to put custom views and put them in a homogeneous or heterogeneous recycler view. And the heterogeneous part is actually really convenient because that gets really complicated with recycler view when you have to try to get the item view types correct. So in order to make this compatible with Epoxy, follow with me here, and then you'll see it'll all come together in a second. We're going to annotate this custom view with model view. And then what this is going to do, it's going to tell Epoxy that this custom view can be used with Epoxy. Then it's going to generate something called an Epoxy model, which is the data component for your actual views. Epoxy then, instead of using your like a recycler view adapter directly, will automatically diff your Epoxy models against what's currently on the screen and only dispatch the minimum set of changes necessary to bring the screen up to date. So here, this auto layout, this is going to be the layout params for your view holder layout that will automatically get generated. So there's some constants that come with Epoxy. So we're going to say we want this to match parent width and wrap content height. Pretty standard for a view holder layout for something like a row. Now we have two functions here, one called setDog and one called setClickListener. Now the dog is really the primary property for our Epoxy model because it contains the data, and whenever the dog changes, we want to re-render that on the screen. So let's annotate this with model prop. This will tell Epoxy to create a dog that we can set on our Epoxy model, and then it'll use its hash code to determine whether or not the view changed. Now we're going to use a slightly different one called callback prop on the click listener. Now, callback prop is basically the same as model prop, except Epoxy won't use the hash code since it's just a lambda and it doesn't have an inherent hash code, and it'll automatically unset it when the view is recycled. Now, let's go ahead and rebuild the project here, and it's going to do a lot of that work you would normally do manually under the hood, like creating an adapter, creating a view holder layout. It's going to do all that stuff with just these three annotations. So if we go back to our dog fragment now, we have the dogs recycler view, and we're going to use a function called with models. Now, and here we just put the Epoxy models. So Epoxy is automatically going to create an Epoxy model with the same name as a custom view. So now there's something called dog row, and it matches exactly the name of the custom view that we have here. Now, all Epoxy models have an ID property. These map to recycler view stable IDs so that Epoxy can get things like notify item moved. So, and this can really be anything. But what we really need to do here is not just create one dog row, but we want to iterate through the dogs from our state. So we'll do state.dogs.forEach for each dog. And now let's just render one dog row for each dog. So we'll say the ID is dog.id. Again, this is the recycler view stable ID. We'll set that dog property from that model prop. And then we'll set a click listener in a minute. Now, we've written a lot of code. Let's see if it works. I'm going to run the app here, pop it up on the emulator. We have our loading indicator. And after 2 seconds, we get the data. Here we have, again, we've took that custom view and we put it in a recycler view without making an adapter, view holder layout, view holder, anything like that. We have no item view types. It's kind of magic. And if our data ever changed, we'd automatically get the right recycler view changes dispatched to the layout. So you would see things move, insert, and all the animations would be correct already out of the box. Great. Now let's set up the details page. So here, what we want to do is set the click listener to go to the details fragment. So we have our click listener here, like that. And then we'll use navigation components again. This is not tied to navigation components, but I've done it for simplicity. So we're going to do r.id.action dogs to dog detail, like that. And it's going to go to our dog detail fragment. And this dog detail fragment is going to look very similar to the main fragment we have right now. So I've commented out some of the code, since it's a little bit easier to explain that way. The first thing we need to do is to change our base fragment from fragment to base Mavericks fragment, like that. Great. And then it's going to ask us to create and validate. Now again, these things are going to start to look really, really familiar. We create our view model property like this. Just need to get everything imported. Dog detail, like that. It's going to dog view model, like that. Great. And OK, more imports. Like, there we go. And one more. OK, so now we pretty much have most of the fragment that we need. Except, you see, we don't know which dog detail view we're going into. So we have a problem. We need to figure this out. And we could maybe say update state and put that current detail view in our state. But we probably don't want to do that. At a future point in the app, you might have multiple dog detail fragments on the backstack. And how would you know, from the perspective of one fragment, which dog you're trying to render? So instead, we're just going to use plain old fragment arguments. They're still perfectly fine. Navigation components support them. And so we wanted to make that easier as well. So let's just comment this out for a minute. Actually, we'll leave that. That's all right. Let's set up our fragment arguments. So this is going to be pretty similar to fragment arguments if you've used them before. So we'll say fun arg, dog ID, long. And it's going to return a bundle. Great. So now I'll say val args equals bundle. And then we need to put this dog ID into the arg. So args.put long. And then so now this is when you would often have to add additional boilerplate to your app. You would probably want to create some sort of key so you can put it into the bundle and then retrieve it out. But instead, we're going to use a magic key called Mavericks.keyArg. And you'll see why that this is useful in a second. And then we'll put in the dog ID and return args, just like that. So this is pretty great. And this feels a little bit magical because we wanted people to be able to use fragment args without creating constants all over the place. So the way we get this out, we never actually need to use that key again. Now, Mavericks is going to help us with that as well. So we know we want private val dog ID. It's a long. And here we have another property delegate that ships with Mavericks that makes things easier for you. So we're going to say by args. So what that's going to do is if you're in a Mavericks fragment, it's automatically going to look in the arguments for that fragment for Mavericks.keyArg and then try to cast it to whatever type you have there. So this makes it really, really easy. We now have our dog ID in our fragment without having to create any new keys. And this is pretty simple for something like a long, but what we found is that by combining this with parcelize to automatically create parcelable data classes, if you have a bunch of arguments for a fragment, you just create one data class that's parcelable, and then you can get access to it really easily like this. You're not tied to a long. It can be anything that's serializable or parcelable. Great. So now that we have our dog ID, if we go back to the original dogs fragment, we need to pass in that bundle. So we're going to say dog detail fragment dot arg dog dot id. Great. So this should be all that we need. And if we go back to our dog detail fragment, we now have all this code uncommented. And let's go ahead and run it and see if it works. We're going to rebuild the app. It's going to relaunch. It's going to load our dogs for 2 seconds. It's going to load our dog. When we click turbo, it crashed. Let's see why it crashed. So we want to open up the stack trace here. Like that. Nope. Let's see. See if we can get that stack one more time. Like that. Boom. All right. So it's missing text view because I changed the name of this from a dot button to love button. There we go. So nothing to do with Mavericks. Simple resource ID. Now when we click the layout, we go to the details page. Awesome. So now that we're here, we want to wire up this love this dog button. So now you see here I have this function that I already created on the view model, but we haven't actually implemented it yet. It's called love dog. And again, these things are going to start to feel really familiar because Mavericks simplifies a lot of this stuff. So we'll go to our view model and create a new function called love dog. And we'll pass the dog ID, dog ID, love dog, dog ID, long. And then we're going to say it equals to set state. And then we need a place in our state to put this. So, we already put it there. So we'll just say set state, copy, love dog ID equals dog ID. Great. Pretty simple. Now if we go back to that detail fragment, this will now work. We can love this dog, and then as soon as we click love dog, we just want to pop that backstack to go back to the original screen. To demonstrate that this actually works, let's go ahead and we have an adopt button on this screen. So we're going to say adopt, let's get this out of the way, adopt button dot set text dot text equals get string r dot string dot adopt dog, and then we're going to give it state dot love dog dot name, just like that. But we really only want to be able to show that button when state.loveDog is not null. Otherwise, there's no point in showing that button since it's the adoption button. So we'll just say adopt button again dot is visible. Is visible? Nope. Equals state.loveDog is not equal to null. And if you remember, loveDog is a derived property that we created that is of type nullable dog. That will either be dog if we've loved one or null if we haven't. So let's go ahead and run that just to confirm that this works. All right. 2 seconds of loading. And now let's pick fuzzy. Great. I love this dog. Now it says adopt fuzzy. Again, we're sharing state between screens really, really easily. Now the last thing we need to do is actually adopt this. So now remember, in our dog repository, we have this function called adopt dog. It's a single that returns a dog after 5 seconds. So let's go back to our state and let's make val adoption request. It's of type async of dog, and it's also going to be uninitialized. Great. So now we have a place to store the loading state, success state, and error state for our adopted dog. So now if we go back to our view model, dog view model, we want to create this function called fun adopt loved dog. And here we want to get the state with state like that. Now we want to adopt this dog. So what we're going to do is we're going to say val loved dog equals state.loved dog. But if you call this before you've loved a dog, that's really not OK. So we're going to say we're just going to throw a legal state exception. You must love a dog first before you can adopt a dog. And now Kotlin's going to smartcast this love dog from nullable dog to not null dog. So now we want access to this dog repository. We've injected it, but we haven't made it a property. So we'll just do private val like that so we can access our dog repository. So we'll say dog repository. Again, it's going to look really similar to the code we have up here. So we're going to adopt dog, and we're going to pass it that love dog. And then we're going to say dot subscribe on schedulers.io. Again, really familiar. And then we're going to say execute copy adoption request equals it. This is all we have to do. Now we need to trigger this from our dog fragment. So we're going to say on view created, we're going to say adopt button dot set on click listener view model dot adopt loved dog. And again, this should be fine and safe to do because we're hiding that button if that loved dog is not null, or if it's null, rather. So this should be pretty good. And now the last thing we want to do is navigate to our adoption screen as soon as that request is successful. So let's go to onCreate here, and I'll show you something new. So you might see here that we've only reacted to our state in invalidate or with a one-shot, kind of with state. But Mavericks provides a lot of tools to make things easier. So if you say viewModel.subscribe, you'll get a Lambda here. And this is basically exactly the same as invalidate. It'll only get called when the fragment is started. It's fully lifecycle aware. And it'll get called anytime your state changes. But sometimes you're going to be a little bit more specific. So you can say viewModel.selectSubscribe, dog state, love dog. And now you'll get a Lambda that's only called when that specific property changed. And again, this is really useful. In this particular case, we're select subscribing on a specific derived property. So if you want to get certain triggers, you can always do that with derived state instead of subscribing to your primary mutable state properties up here. But there's one that's even more convenient for our use case right now. Remember, we want to navigate to the adoption fragment as soon as that request is successful. So instead of checking for the type up here, Mavericks makes that easy. So we're going to say viewModel.select or .async subscribe. And this is a special version of subscribe that's specifically geared towards making these async operations easier. So we do dog state.adoption request. Now there's two optional parameters, one for on success and one for on error. You can use this for analytics. You can use it for navigation. We're going to use it for navigation in this case. So when it's successful, we want to find navigation controller.navigate r.id action dog to adoption. And if we go to our adoption fragment, which is right here, we'll just uncomment some of this code. Again, it looks super similar to the code that we've already written. We have private val view model, where we have a view model. Let's just get all this to import, like that. And then everything works out. You'll see here there's even one additional epoxy model we've made called title row. Now, title row, it's another custom view, just like everything else. There's only one difference here, that we've annotated this function with text prop. Now, text prop, if you give it a char sequence, it's also geared just to help you out. Because in the property that you get from Epoxy, in the Epoxy model, it gives you an automatic overload for the Android string resource. So here, we can put the string resource in here, and it'll automatically do the right thing under the hood. And again, this also highlights the power of Epoxy, because this will get called automatically when the state changes, and you have a heterogeneous recycler view now without having to worry about view types and making sure that you get that state correct. So now we have an adoption fragment with a title row, and it's going to show the adopted dog from the adoption request as soon as it's done. So let's go ahead and run the app. All right. We'll go ahead and say we like Turbo first. Say I love it. Now it says adopt Turbo. If we scroll down, how about maybe actually Happy? You know, Happy came a little later. Say I love this dog. Adopt Happy. And I don't think we wired up that click listener, did we? So dog fragment. We want to say here. Let's make sure we got this right. Oh, there we go. It went after 5 seconds. We just didn't update and validate. So what we want to do right here was we want to say that loading animation, we want it to come back after state.adoption request is loading as well. And for the recycler view, we want that to go away only when equals state.adoption request is uninitialized. OK. So this is going to make that recycler view go away. We'll get that loading indicator back. And then we'll go to our adoption fragment. So we'll say Jules, I love this dog, adopt Jules. Now, again, this is automatically, we don't have to wire anything up. This just happens automatically. After 5 seconds, we go to the adoption fragment, and we've just written 2 apps in about 30 minutes. So I hope this shows some of the power of Mavericks. I know we covered a ton. I'm pretty much out of breath. I know it's probably hard to retain all of this in one talk, but I hope this gives you some of the ideas so that you can go and check out our GitHub wikis for either Mavericks or Epoxy. We now have a Caster.io course for Mavericks, which covers all of this and more. And I'm always reachable on Twitter. My handle is gpl8 if you have any questions. And finally, I'm going to just hang around back here. If you have any questions, just come up and talk to me because we're just about out of time. So thank you very much.